A very good morning and selamat sejahtera to my lecturer, Professor MADYA ROSEMIZI bin Abdul Rahim, my friends and all the viewers. We are students from University Malaysia PERLIS. We are doing a mini project titled Automatic Vehicle Control System. We are from Computer Engineering students RK20. We are doing this project under Modern Control System subject EKT318. We are from semester 4 students under session 2019-2020. Let me introduce myself, Privinraj, son of Puspa, Rajan, and my other members are TERRANCE, PRASATH, son of SURIYAN, MANITHIBEN, son of MANIMARAN, and SASHINDREN, son of MAGINDRAN.
Hi, good day everyone. My name is MANITHIBEN, son of MANIMARAN. My ID number is 181021072. I'm from RK20. I'm here to give my introduction here. So, first slide is introduction. Automatic control vehicles is one of the promising method of automating many jobs without need of a human interaction with the system. That can be very useful in many applications. It can be used in warehouse, airports, wheelchairs, and others. For example, the system can be filled in vehicles that are used to transfer cargo from place to another within the airport. Software and mechanical hardware are seamlessly integrated in this project. We did our best to assure that the user of the system can be assured that he will reach his destination safely. Moreover, we try to design the system so that can be easy to be implemented for other application for future development. So next is objective. To find out the solution of this problem and simulated in Skylab software to get the board plot and calculate the gain and phase margin of the system. To elaborate on automatic vehicle and test the system stability. Thank you.
A very good morning and selamat sejahtera to my lecturer, Professor MADYA ROSEMIZI bin Abdul Rahim, my friends and the fellow viewers. I'm going to narrate about the aim for this mini project. First of all, it is to evaluate and determine the stability of the system of an automatic vehicle with a transfer function. Other than that, the stability of the transfer function can be determined by finding the gain and phase margin in order to reveal the gain and phase margin of the system using the board diagram. However, the board diagram can be calculated by hand will be a little bit different from the actual value. This can be determined and examined by using Skylab, Octave, MATLAB, and so others. Finally, it is to improve the human race in terms of effectiveness, cost, and to reduce the human intervention. About the methodology we use in this mini project, the system is configured by serving the open loop transfer function of the automatic vehicle control system. The equation is Ls equal to kV over S bracket S over pi plus 1 bracket square. The Skylab are used to get the phase margin and gain margin based in the self open loop transfer function. By obtaining the board plot, we analyze the system rates and configure it to our desired phase margin given by the question, which is a compensator lead or lag to about 30 degree. Here we come to the system advantages of our mini project. The system can be easily implemented as the parts required are widely available. Few components can be added to get extra features based on our user needs. It is cost efficient and can be used in transportation of goods and personal use or dangerous areas human cannot reach. While for the system disadvantages, the system not might be recognize other drive reaction and local human driving ethics. It changes the road condition could be dangerous since not every road are made perfect since same parts are not well maintained. Finally, the road rules and regulations from all over the world are not same. This is why the system needs to be configured to accurately detect the traffic rules from different countries worldwide. Here we come to the result and discussion of our mini project. I will let my friend to explain in detail about the result and discussion. Before that, I will explain about our question we have chosen from the title given. We have chose the question 11, which is the driverless vehicle can be used in warehouse, airports and many other applications. Open loop transfer function of an automatic vehicle control system is given by the equation ls equal to kv over s bracket s over pi plus 1 bracket square root. The first option is the draw a both plot of the system and be determined by the gain and phase margin of the system. Assume that kv equal to pi. Okay, option B, you are required to design a compensator layout lag so that the phase margin will be at least 30 degrees. Produce a design, you are allowed to use Skylab, MATLAB forever. We have used, even we have used Skylab, Octave and MATLAB. So we have produced the result using the Skylab only in this discussion. Thank you.
Given the transfer function gs equal to kv over s times s over pi plus 1 power of 2, given k is equal to pi, so we can conclude that kgs equal to pi over s times with s over pi plus 1 power of 2. Then we will factorize it, then it became pi times 1 over s times with 1 over s over pi plus 1 times with 1 over s over pi plus 1. Then we will factorize it, we'll substitute the kgs into kg j omega, then became pi times 1 pi times 1 over j omega times with 1 over j omega over pi plus 1 times with 1 over j omega over pi plus 1. Then we will find the magnitude. Then became 20 log kg j omega equal to 20 log pi plus 20 log 1 over j omega plus 40 log 1 over j omega over pi plus 1. Then from there we can find the find the pace, which is equal to 1 less pi, which is equal to less pi plus less 1 j 1 over j omega plus less 1 over j omega over pi plus 1. So from that we can draw the pace and magnitude graph, and we know that we need to shift at least 30 we need to shift the system at least 30 degree.
Hello everyone, my name is PRASATH from EKT318. So today I'll be explaining about the board plot that we did in the Skylab. So basically we have the transfer function. So first input we should give as s equals %s, and followed by the numerator, which is 3.14, which the question given is pi and 3.14, and followed by the denominator function we need to give as 0.1 s cube plus 0.64 s square plus s. And moving on to the next function, which is the tf equals syslin and c comma numerator comma denominator. Basically this function will obtain and show us the transfer function, which is 3.104 over the denominator. So after inserting that, we have obtained the phase margin, which is 21.71, which is in degree, and we also have obtained the value of gain cross over frequency. It is gain crossover frequency, yeah, which is in hertz, and we need to convert that to radian soon. So as the question required, where we need to shift this at least 30 degrees. So yeah, this is the board plot you guys can see, which has the phase, and magnitude. You guys can see it. Yeah, phase and we guys can see it is at 5. So yeah, it's not at 5 yet, so we need to shift that to at least 30 degrees. So to do that, we need to do some calculation.
We will find phi max, which is q equal to p required plus p current plus 15. We will substitute the value, then will become 30 minus 21.46 plus 15. Then the result will be 23.3. We know that p currents is equal to 21.69. Frequency is 0.34 hertz, but we need to find omega c. So the equation is 2 pi f. So we'll substitute the frequency into the equation. Then the result will be omega c equal to 2.136 radius per second. From here we need to find alpha and tau value. So to find the alpha value, we need to substitute q, which is phi max, into this equation, which is q equal to sin power of -1 times with alpha minus 1 over alpha plus 1. Then after we substitute it, it will be 23.3 equal to sin power of -1 times with alpha minus 1 over alpha plus 1. Then we will substitute the values and we'll solve the equation, and the end will, and in the end the alpha answer is alpha equal to 2.308. Then we need to find tau, which is we need to find omega m, which is also equal to omega c. So omega m is 2.136. From here we need to find the tau using omega m equal to 1 over tau times with square root of alpha, square root alpha. So we'll shift the tau into we'll do the equation, become tau equal to 1 over omega m times with square root alpha. So we'll substitute the value, and the tau is equal to 0.284. Then we will find cohesion of the compensator, which is GCS equal to 1 plus alpha tau s over 1 plus tau equal to 1 plus 0.66 s over 1 plus 0.2845. And then we need to install the compensator into the system. So we need to last calculation, which is GCS times GS, which at the end the result will be 1 plus 0.66 s over 1 plus 0.2845 times with pi over 0.10 s power of 2 plus 0.64 s power of 2 plus s.
Where we have the peak current is 21.69 and the frequency we have, which is 0.34 hertz, and the omega we know, which is 2 pi f, and we substitute the value in and we'll get the omega in radian, which is 2.136 in radian. And we have the phi max, which is q equal to sine a alpha minus 1 over alpha plus 1, and we have the phi max, which is 23.3, so we can just substitute the value in. After substitute the value in, we will get the omega m, which is 2.36, yeah, 2.36, and there's a formula which is omega m equals to 1 over tau square root of alpha. And basically if we switch the formula to just move around the formula, where we'll get tau equals to 1 over omega m square root alpha, and by that we just substitute the value and we'll get 0.86. 86, yeah. So basically GOS GC of S is equals to 1 plus alpha tau S over 1 plus tau, and where we will get 1 plus 0.66 S over 1 plus 0.2845 value. So to get the last dot plot, we need to multiply GC of S and G of S. So to do that, we need to give a new input to the Skylab again. So yeah, the new function will be, we have given the same thing, numerator and denominator, and define a new constant, which is numer and denomi. So the numer and denomi will put the old value, and the numerator and denominator will put the GC of S, and the above one, it is G of S. So basically we need to times both of that, and we need to give a function which is TF equal to syslin C comma G. And the phase margin here, we get approximately 29.09, which is close to 30 degrees, and I think we have successfully shifted to 30 degrees. And the gain crossover frequency is 0.45. So let's take a look at the dot plot. This is the last dot plot. So as you guys can see, just now it was at before 5, and now you guys can see it is like more exactly to the 5. So yeah, if you guys can notice the value of 0, it is at 5. So the previous dot plots, as you guys can see, where the value of 0, so yeah, the old dot plot, you guys can notice that the value as 0 is before 5. So yeah, thank you, that's all from me. Moving on to next point.
Finally, here we came to the conclusion. My name is Privinraj and Puspa Rajan. I'm going to conclude the overall project in a few words. This conclusion lit a compensator. It has a 0 closer to origin of the pulse. It improves the transition response. It helps to increase the error constant up to some extent. It allows to pass a higher frequency and attenuates lower frequencies, and also increase the phase shift. The system should become more commonplace with the passage of time. People are living in a networked world and constantly feel that they have less time on their hands. It has been jokingly said that the more developed a country is, the more time its citizens waste behind the steering wheel. To protect this technique, it might take several years, but the project is surely a step in the right direction. Prevention is better than the cure, so that instead of treating patients after an accident should be prevented by incorporating the system. Thank you. That's all from us. Thank you for watching. Hope you all like it, and do like this video, and do not hesitate to ask us questions or leave your comments under the comment box regarding this project. Thank you.